So you see, I am very old. Yes, very old. I am a mathematician, and I like to talk something about myself because it is possible. It is for possible future contacts. In 60s, I had postgraduate studies at Moscow State University. After then, I defended my PhD in medical engineering. The key point was heart modeling, heart rhythm modeling. And next, my PhD was in telecommunications. It was about telephone exchange throughput modeling. And from that time, I'm very active as critics on Pentagon results in telecommunications. You can find these my papers in internet. But now I am returning back to my medical interests, and we are working for several last years in cancer treatment. And this my team here, this my colleague is one professor from medicine, from immunology, and one guy is from mathematician. He is expert in modeling. And the very problem, this insight into immune system, I think that is really immune system and cancer research. It's very sophisticated problem. And of course, this knowledge from immune system would help to develop some tools for cyber defense. So, and of course, you can find these details in proceedings. In any case, we can start. No, which one? This one? Oh, yeah. Content. So there are four points. First is to attract interest of mathematicians in immunology. Second one, to look for ideas for cyber defense systems, considering human immune system as a highly sophisticated defense system against any dangers. And then my interest during last few years is in melanoma. It's very, very hard case in cancer treatment. And the last point is some experience of the US Army Cyber Command relating to cyber defense. So immune system is something very sophisticated. There are two immune systems. One is innate immune system, which is innate for each person. And second one is adaptive immune system because of some pathogen in our body. And so there is reason to call two excellent persons, Ilya Mechnikov from Odessa first, and then he was with Pasteur in Paris, and next one is Paul Ehrlich. They received Nobel Prize in physiology and medicine, because they developed some understanding how phagocytes is moving. You see, there is some food particle, how is moving through, how is all process, how this particle is moving to inside cell. Our next one is there's details about the process of phagocyte, how this absorption of pathogen is moving, everything happen. Next one, what is more important in immune systems, it is study lymphocytes, B cells and T cells. These are main key fighters against infections. And to understand something in immune system, we need to know how immune system is built and where this lymphocyte sources. They are the birthplaces, bone marrow in bones, and they are moving in all body, all our body. And the very important point is this thymus or thymus, how to name. There is these cells are maturing. Of course, it is necessary to know all this process, how this immune system work. And thymus is very interesting lymphoid organ, or thymus, let's say. So, because T cells born in the bone, what is called, and they are migrating to thymus, and they are maturing, and they receive some knowledge about pathogens through T cell receptors. In any case, thymus is extremely interesting lymphoid organ. Next one is about B cells, also lymphocytes. B cells, they are very important. There are four steps what B cells are doing. At first, they are binding antigen in cell. They are moving. They receive this antigen, and they are moving through plasma. So first point is to bind the antigen, then to receive help from related T helper cell, then to differentiate into a plasma cell, and then secretes antibodies. These antibodies against this pathogen. And all these results are there for all these results there are several Nobel Prizes. It's important to know all these results, how nature was that the secrets from nature, how these secrets were unclosed. Next point is, so dendritic cells are really nature's miracle. How do they work? Dendritic cells, they are professional antigen-presenting cells. They capture pathogens, receive signals from these pathogens, and they are moving to through lymph nodes, where they interact with T cells and B cells, initiating these cells and shaping these cells to adaptive immune response. It's very, very interesting, this result, and key person who recently received Nobel Prize because of unclosing this nature's miracle. Next, there are several immune system models, and the newest one is danger theory. It is very sophisticated picture. I don't know explain. I don't need to explain in detail this picture, but what is important that this danger model was formulated by Maksims in 1994, and this during 30 years. There is nothing new. It is really very hard to understand and to move something new in this immune systems. Next one about mathematical modeling. The most popular models are so-called Volterra predator-prey model, where wolves and these hares are competing for food. It is simple to differential equations, but it's the basic model, very popular. And there is example of how using this Lotka-Volterra model is it possible to explain cancer, how cancer is developing, and there is two types of cells, drug sensitive and drug resistant cells, and this is similar as in previous picture. Next one is more complicated. It is a oncolytic virotherapy model. So there is reason to talk something about my interest here. Today, only five viruses are undeveloped or uncloned, found in all the world. Only 5 viruses. And the first one is so-called Riga virus, which was unclosed in 60s. And this is only natural virus. All next 4 viruses are developed through genetics. They are genetically modified viruses. And so this is one model how to describe this influence of these viruses on tumor or cancer cells. This one. So next is my interest because I started my last few years to understand what is melanoma. Melanoma is really very dangerous type of skin cancer. It is usually as pigment on our skin, but during this developing, in third stage, this melanoma is is going through our skin, and there are metastases distributing through our cell, and it is very hard case for treatment, melanoma. And yes, and this virus in Riga developed in 60s, so-called Rigvir. Rigvir is virus. At first it was natural virus, so this virus has not any side effects, because all our treatment usually are connected with some virus, some side effects, and this one in this product, it is as food supplement one times in month for protecting against viruses, against cancer. This is I received recently from London. It is developing in London this kind of medicine. Next is how this fight against melanoma by immune cells is going. This part is innate system, innate immunity, innate part, and this one adaptive part. It's extremely complicated picture. To describe this picture, it's necessary at least some 20 equations to describe. And we are now looking for this study, how to develop this. This is how to receive results from doctors. Of course, recently, really, it is very hard to receive this melanoma histories, melanoma stories about from patients. But in any case, this is our interest for all this research. And next, one more next. So now about cybersecurity and biological inspired computing. This biologically inspired computing is based on genetic algorithms. It is in medicine and some knowledge of evolutionary processes. And next one is these results of last period results from artificial intelligence and artificial neural networks. And the next one is describes this detecting of cyber threats through sensor networks. These are so-called artificial innate immune systems. And cyber immunity is based on the human adaptive immune system. Therefore, it's reasonable to study indeed this adaptive immune system. But as I said before, it is very, very complicated. So what is, so really this is something about this artificial immune system. There is I called only danger model preview in this slide. some slides before. But before danger model, there is also so-called self or non-self immune system models. And based on these self or non-self models, they now are developed three types of algorithms, so-called negative selection algorithm, positive selection algorithm, and clonal selection algorithm. All these algorithms have some similarities with neural networks. And what next? I'm interested in how Pentagon fight before cyber threats. And the very hard point is that this in some 40 years ago, all telecommunication systems were based on so-called circuit switching. But when internet started, then Pentagon also moved to internet, to so-called packet switching. In this case, all these warfare objects have its IP address. So all warfare is going in internet world, and therefore there is sources for cyber threats. For example, in 2018, Government Accounting Office reported this was sensations that all software-based weapon systems tested between this 5-year period have cyber vulnerabilities and can be hacked. This is prototype, but in reality, this is fighter F-35 seems the biggest Department of Defense failure today, because they don't know what to do, because there is so many places for cyber attacks, and they don't know what to do, how to finish this project. It is a very interesting point. And next one, also very scandalous fact. This is so-called single security architecture. This architecture is based on so-called joint regional security stacks. This picture is about hierarchy, how this architecture is built. There are two, this NIPR and CIPR. They are two email systems. This is non-secret, this is secret system, and the most top secrets are connected with this national security agency and so forth, and the cosmos. And what happened? Unfortunately, after long time and after 2 billion spent to develop this so-called joint regional security stacks, Pentagon suspended this program because these stacks were too slow and did not meet bandwidth requirements. Now, artificial intelligence and so-called cloud computing models are as a great hope. Maybe, but in any case, this point is very hard point because they are not able to fight against cyber these threats. So in inclusion, so searching for parallels between human and artificial immune systems may offer revolutionary solutions. And there is still a long way to go in the research of biologically inspired computing for cybersecurity and artificial immune systems. Thank you. I am, yes.
Thank you, Manfred. Any questions?
So, yeah.
Thank you so much. That concludes